All right, let's finish up talking about the predefined functions for the arrays. As you can see, arrays are complex and advanced data structures. They have the capability of storing many elements of the same type. Also, they come with their own functions and variables that are quite helpful, and you can solve a lot of problems with them. Let's make sure we understand exactly how these functions work. Now, your knowledge of functions comes very handy here. So it's important that you understand exactly what's happening. If you have three arrays, A, B, and C, and let's just do one of these functions. Let's just do shorten. So if I say A shorten B, it's very important that we realize that, well, first of all, B is the argument, right? So this is the input, and this is the output. So function shorten takes B as input, takes array B. In its own scope, it's going to make the changes to B. In this case, it's going to make it shorter by 1. And then it is going to bring the result and copy the result into A. Okay? So no changes are going to happen to B whatsoever. So let me tell you what I mean. So if you have the memory diagram, so we have A. It has 5 cells. So 0, 1, 2, 3, and 4, and inside you have zeros. Then we have B, which has 11, 12, and 13 inside. And we have C that basically has nothing. Okay, when I say A equals shorten B, what happens? What ends up happening is B is passed as input, and shorten, what it does, it takes an array, pops the last one out, and then copies the result into A. So actually, A contains this, but just as, you know, if you have a file and you copy something on top of that file, the original file is going to disappear, right? If you have a CD, it has a certain content, you copy over that CD, the old content is going to be lost. So this guy is going to be, this is going to be gone, right? It doesn't exist anymore. So I'm just going to erase it. Memory doesn't really get erased. It just gets sort of dereferenced. So it just sits there in the background. It just becomes garbage kind of thing. And A is actually going to contain what shorten returns. What does shorten return? Shorten returns B minus the last element. So 11 and 12, and it's gonna have 0 and 1. Right? So the input doesn't change, the output changes. Now, this is, you have to take my word for it, a little bit later on in the lecture, we're going to learn how to pass our own arrays to functions, and then you're really going to get what's happening. So actually you're going to write your own shorten function, and you're going to be doing what the shorten function does. So in a little bit, we're going to write the shorten, and we're going to write the append functions for you, and you'll be able to see exactly what these functions do. So they're predefined functions that make your job easier. But guess what? You could write user-defined functions that do exactly the same thing. Another thing that's very, very important that you have to realize is that the input I should say the input array cannot be an empty array. Okay, so you can't have, so if you pass B to shorten is going to say, okay, well, give me this. I'm going to take one from the end. So even if there is one element at the end, it'll take it and it'll take it off, and then it'll basically A will become an empty element. So if you end up giving it an empty array, it can take one from the end. So that will mess it up. So this cannot be an empty, but this could, right? Now, if I go ahead and if I say B equal append B and 10. Now here, this is input, and it just so happens that B is also the output. But the function doesn't really care. It just takes B, it adds one to the end, sends it back, and it's going to be... Huh, that's funny. I just realized you don't get some of my hand motions. So basically, it gets function, it gets B, does what it's supposed to do, and then it just sends it back, and it shoots it back here, and whatever is here to catch it, it'll catch it. So basically, it's going to copy the value into B. So append here, in this case, it's going to take B, add 10 to the end, and then bring it back and copy it into B. So now in this case, the input and output are the same array. So 10 is copied into here. So that should be very clear for everybody. Let's have a look at processing. So I have the same thing copied in process. So if we have array A and array B, and if we don't have the shorten function call yet, and I just run it to see what's in B, you see 11, 12, and 13. And if you run it to see what's in A, of course, we have 5 cells filled with zeros. Now, if I have the shorten function, if I have A equals shorten B, that means I'm sending B to this function, and I am receiving the result and copying into A. So A, now you see it has changed to 11 and 12 as we did show on the memory diagram. So you see that the content of A now is an array with 2 cells filled with 11 and 12. Let's see B. B, of course, has not changed at all. 11, 12, and 13. If we were providing B as input, and if we were getting A back and B, and if we were storing the output in B, then you can see B changing to 11 and 12. And in this case, of course, A has not been changed at all. If we have array C, so it's perfectly fine to say to copy the result of this function into C. That's perfectly legal. So I can say take B, shorten it by 1 at the end, and then display the results. So if I say print C, You see that 11 and 12 are printed. So C now is an array of its own, and it contains two elements. However, if I said, okay, well, array A, if I said to shorten, take C and proceed to shorten it by 1 and send it to A, it doesn't make sense because C doesn't have any content. So when you run it, you see that it gives you an error. The same thing works with all these other functions. Basically, if you're going to send an array to them, you have to make sure that that array is not an empty array, that it does have cells. It doesn't matter if they're occupied by 0 or anything like that. It's just that it needs to have elements inside. So, if you go to processing, well, I'm just going to go a step back. If you go to processing.org and you go to references, and this is a great place to go and study and look at these functions. So this is excellent material in addition to what we teach in the course. Internet is programmer's best friend. You need to take advantage of this resource. If you go to data, you have primitive data members that we've talked about. Then you go to composite data members, which array is the first of them. Then here, if you go a little bit down, you see array functions. And these are the functions I am talking about. So there's a whole bunch of them. You see append. They show you an example. Then they show you the syntax. So append takes an array and then it takes a value which is an integer. Or it could be other kinds. So it does get a little bit complicated, I guess. But from what as far as we're concerned, we're not going to go into too much details. So there is a limit to what you're actually doing in the scope of this course. So you see other ones, for example, sort. Sort is an interesting one. You see there are a couple of functions for sort. One just takes a list and one takes a list and a number, and that's function overloading, right? That's having functions with the same name but with multiple with different arguments and different types. So that's function overloading. With sort, let's do a quick example with sort. So if I have, let me change A. So if I have array A, and I'm just gonna say like 23, 44, 8, 1, 100, like a random array. And if I say A sort A, so that means this is going to take A, it's going to sort it in the increasing order, and it's going to bring and copy the result to A. So let's print what A would look like then. So if you did this, the algorithm is going to run, and now our array is sorted. So in memory, A is sorted as 1, 8, 23. So it's completely, the data is rearranged. That's what you have in memory. Now, if I said sort A, but put the result in B, you see that A is unchanged now, right? Because I'm copying the result into B. If I run it and now display B, B contains 11, 12, and 13 in memory, but when I run it, now it contains 1, 8, 23, 44, and 100. As we're going to, so basically, you guys know functions, you guys know arrays. You should be able to go through all these and basically figure out what they do. As I said, basically when we learn how functions are passed to arrays, we're going to be able to write all these functions ourselves. So you're going to write a function called myAppend that's going to receive an array, add one to the end, and return it back to the calling function. So that's coming up in this stuff that we're going to talk about. All right, let's talk about copying arrays. Actually, before talking about copying arrays, let me just talk about one more function really quickly, and that is function expand. Oh, I closed that. So it's function expand, and let me go back to it really quickly. So I'll go down here, the list of functions, and I'll see function expand. And so going through this, if you have, so let's go through this example. If you have an array that has 1, 2, 3, and 4, so if you said println and tell me what the size is 4. If you say data equals expand data, it's going to take array data and it's going to basically double it. It's going to double how much it has, how many elements it has. So it's going to print 8. And if you say data expand data and give it a value 512, now the length of this will become 512. So these are things that as computer programmers you should be playing around with. So function overloading, one kind is it's just going to take a list, take an array. The second one is it's going to take an array and actually the new size. So expand, it's not the best name for this function because technically you could take a function and decrease the number of elements that it does have. Let's do some work with this. So let's just let's just have function b, and I'm going to say, well, actually no, let's have a in there too. So I'm going to say b equals expand b, and then we're going to print b. So that's what we get. We double it, it's going to become 11, 12, 13, and it has 3 values left over. Of course, input is b, output is b. So if I say copy the result into a, what happens? Right? Can you predict what a is going to be? A is going to contain, printed B. So you see that in this case, B is the input, not the output. So B hasn't changed at all. If I print what A contains, it contains B expanded by double. The other feature of so if let's change this to B again. So B is the input and the output, and let's see what happens. So if I said extend B to 10, what happens is it's going to keep the values of B and so 11, 12, 13. And then you have a bunch of zeros. So it expands the size to 10. I could also say change the size to 2. So perhaps the best way, the name resize is used in other languages. So resize would probably be better, because if I said to resize this to 2 or expand it to 2, what happens is this is going to become 2, and it only contains 11 and 12. So what's the difference if what is the difference between expand and just using the new operator? Let's look at that for a second. So if we had int a, or let's say 11, 12, and 13. This is 0, 1, and 2. Now, if I said a, let's have two scenarios, right? So scenario number one, I come and I say a equals expand a, let's say make it into 5 cells. What happens is this is going to keep the values that I have, and it's just going to add 2 more cells and initializes them to 0. So this is going to be 3, this is going to be 4. Scenario 2 is if I said a equal new int 5. If I said this, what happens is what I already have is going to be destroyed, and a actually is going to be 0, 1, 2, 3, 4, like that. So that's the difference between expand and the new operator, which makes an entirely new array. All right.